coming to this session. We're going to talk today about how to connect applications across the hybrid cloud. Okay, so it's something that you might think about, oh, this is about ops problem. And partially it's true, it's an ops problem, but also it's a depth problem. Or, I like to say it in another way, is that as you will see today, if you move this problem into depth space, things become easier, okay? Because usually, all the infrastructure parts are quite difficult, okay? So today we're going to see how to solve this kind of problem. So, the slides are in this URL in bit.ly hybrid cloud scupper, okay? So, I think that you should be able to see the slides. So let's start. My name is Alex Soto. My Twitter is AlexSotoB. My email is asutoboy@redhat.com, and I'm the co-author of all these books. And I would say good news for you is that if you go to developers.redhat.com and you register, then you can download it for free, these 3 books: the GitOps Cookbook, the Red Hat Certified Engineer Ansible Automation Study Guide. So if you want to certify this with Ansible, you can download it, the guide for free. And then also, and this last book is now is under development, is the Applied AI for Enterprise Java Development. So basically, it's AI and Java and so on. Okay, so basically, nowadays, organizations rely on applications that are probably deployed everywhere. Maybe you've got some applications that are in Amazon, others maybe are on-prem, others maybe are on Google Cloud because, I don't know, you want to use some kind of great feature of Google. Maybe you also have some edge computing, right? Some edge elements there running, for example, with RHEL or OBI, and yeah, maybe you've got some old applications maybe running in the, on IBM racks or something like that. Okay, so you've got a lot of let's say places where you're running part of your application, and exactly for this, because you've got all this ecosystem, is what delivers value, right? So you have your application delivers value because you are using all these kind of parts. Then you need to connect all these parts. And of course, and that's the most important thing, is that all these interconnections must be protected, right? Because we do not want to do, some kind of request from Amazon to Google Cloud, and you're sending some data that should not be compromised, and for any reason, someone just sniff the traffic and just get it, all this information. So you need to also protect this. Then, simple questions about this kind of applications. Simple questions, but maybe the answer is not that simple. First of all, it's like, okay, are you struggling to connect your application together across hybrid environments, right? So I've got my application. Maybe I've got all my application in Amazon, okay, but I've got one application running in one region, and then I've got another application running in another region, and I need to connect. Are you getting, struggling to connect these 2 applications? And sometimes you might say, why I need to have this kind of setups of having different regions? Well, maybe sometimes it's because of performance. Maybe sometimes it's for for some laws that don't let some data get out of the country borders and things like that. Another is like, are you struggling your cloud applications connecting your cloud application securely, right? Suppose that I've got, now I've got that for a long time I've got my database running on-prem, and now I want to move to the cloud. And okay, my application will be in the running the cloud, but my database will run on-prem, still on-prem, okay? So how I can connect these, scenarios, but securely. How are you dealing with cloud migrations? Of course, you've seen here this example of I've got my database on-prem, I've got my application, the backend in the front end in the cloud, but at some point, probably you will love to move also this on-prem workload into the cloud. How you deal with these migrations? Are you struggling with this? Maybe you said, oh no, because we move everything. So we just, we move the database, the backend, the front end, everything to the cloud. Okay, it might work. The problem is that if you get any kind of error in the middle, yeah, then it's super hard to find it. Instead, if you start moving things piece to piece, right, so with smaller steps, then it's easier. But again, if you want to do it smaller steps, so moving small parts from on-prem to the cloud, how you do that in a not big bang concern. How you build this cloud portability, right? Suppose that you are using, for example, Amazon Lambda, and then you want to move to Microsoft Azure. So you need to migrate your Amazon Lambdas into Microsoft functions. Oh, are you worried about this kind of lock-ins? Or maybe you say, no, because, I mean, that again, the same example as before. I've got my application running in Amazon or in Google, but in different regions. And I'm connecting them with some tools that offers to do that kind of things. But again, this is a locker, there is a lock-in on this technology. Are you worried about this? And after all of this is like, okay, great. Now, the last thing is, if you put everything in the cloud, what happens if the cloud goes down? I know you might say, oh, I'm sure this is not going to happen. Well, remember some years ago that S3 goes down and half of the internet or the web pages were down because S3 was down, right? So how you can deal with this kind of problems. So you can see that, first of all, we are talking about connectivity, how we connect these applications across the cloud. Then it's about the portability, how we move our applications from one cloud to another cloud or use different clouds. And the third thing is about scaling and high availability. So it's like, okay, what happens if the cloud goes down or one part of the cloud goes down? That's what we're going to see today, okay? Now, first of all, and the most important thing is how we connect between these applications. The first way, you might say, oh yeah, I'm using public IPs, right? I create one route somewhere for example, in Amazon, another route in Google, and then I connect it. Just with a public IP. That's fine, it works, but first of all, you are not having network isolations. If you are behind a firewall or a net, then there is no connectivity, and of course, each public IP costs money. That's one way. Of course, you might say, no, because we are using a VPN. Great, now we've got network isolation. The problem is that it's super complex, right? I don't know if you ever tried to configure VPN, but it's complex. And then also there is all these AP tables and firewall rules. So when you want to deploy another application, then this application needs to be updated in all these rules and requires administration privileges. So VPN works, yes, but it's hard. Another option is using the large provider networks. Basically, it's something that the cloud provides you to connect. So for example, if I got my Amazon application in one region and my other Amazon application in another region, I'm able to connect them. It works, but there is a vendor lock-in, requires cluster privileges, and of course, Amazon will say, oh, you want to use this feature, great, but this costs money. So the last option that I want to show you here is Scupper. Scupper is an open source project. It's Apache v2 license that lets you fine-grained network isolation. So you're not isolating all the network, but only the parts that you want. It has a really low complexity. You'll see it's super easy to understand what it does and super easy to use it. It's developer controlled. So it's the developer who does all these things, and yeah, it's a very very low cost for you don't need to pay anything. And what is even more important is that you do not need administrator privileges. This means that no more complex AP tables, firewalls, nothing. Okay, so a Scupper. As I said, Scupper, it's just a project that lets you secure all the connectivity across platforms, clusters, and clouds. Okay, it's application-focused connectivity, so it works in the application layer. So no firewalls, no AP tables, no VPNs, nothing. Automatically encrypts all the communication using MTLS. So all the communication between the clouds, between the platforms, between all the applications are by default encrypted. It works at application layer abstraction. This means that if you are been using other tools that do similar things, they are working at level 4 of the network stack, which needs administration privileges, and it's super hard to configure. Scapar works at layer 7. It works at application layer. It means that it's super easy to work and no special rules, because it's like another application that is doing things, right? That is doing managing connection. It's connecting across sites, things like that. So how it works, Scapar. Okay, let's suppose that we've got, this is just an example, you can make it as complex as you want. We've got an edge application, okay? Suppose that, I don't know, this can be a bus, okay? And the bus has some kind of, of computer that it's, calculating the number of passages or whatever. Okay, we've got some kind of the edge computing. Here, we've got here the application. It could be also a virtual machine. It doesn't matter. It's just one application. Then we've got another application which is deployed in the public cloud. Amazon, Google, whatever. Microsoft Azure. And then also we have another application. And remember that this application can be a database or whatever. That it's in a data center. It's an on-prem. It's on, an our site. And we want to connect all these applications. That's the thing that we want to get. So the first thing that we need to create with the Scapar is the concept of service. Okay, the service, you can think it's like a proxy. It's not a proxy, not a 100% proxy, but you need to think like this is like a proxy. Then this proxy has a Scapar router. And this is because basically at the end you've got your service and you need to be able to discover other services. And this is what it does, the Scapar route. Then this Scapar route is installed in all the processes or applications that you want to interconnect. So you can see that in this case, I'm just creating a Scapar router here in the data center. So this is on-prem. And then I create another Scapar router in the public cloud for this application. Now at this point, these two routers can communicate using TCP over MQP. MQP is just like, a protocol at TCP level that lets you connect applications and uses TLS. So it's secure. At this point, thanks of this router, I've got this data flow, right? I can send data from this part to this part. Finally, what I need to create is a new service here that, again, it's like a proxy. That is the one that represents this application. So now what I've got is my on-prem cluster with my application and a service. A service is, like I said, is like a proxy. And then here I've got another cloud with another application with another service. Basically, since I need to identify my applications, these services are the ones who give us a name. You can think like it's kind of Kubernetes service, right? That provides you some stable IP, stable virtual DNS name, and so on. You can think it's kind of the same. Then I want also to connect the edge part of the application to the other part of the cloud. So I connect both of the routers. So now I've got the edge router connected to the public cloud router. And one of the great things about the Scapar is that it's smart enough to say, oh, if you are connected this with this, and I connect this with this, then this edge is also connected to the data center. Not directly, of course, but if I say that the edge wants to communicate with the data center, it's super easy. I send the package here, and then here goes here, right? So Scapar knows to do these kind of things. And of course, here we also need this virtual service. So this gives us a name. So now we've got here a edge service, here a public service, and this is a data center service. Then if I want to connect the edge service or the edge application to the data center, what I need to do is make a call, an application call, to this service name, okay? Because a scupper creates kind of a mesh of all these services. Now, how you run a scupper, how you build all this kind of stuff, it's easy. Suppose this. I've got in my laptop a PostgreSQL database. Now I've got a public cluster. Now I've got a private cluster that has a hero service, basically the backend. What I need to do, first of all, is this. Run scupper init. A scupper init that I need to run it in every of the cloud. What it's doing is installing this router. Okay, so basically, let's say that it's installing all the stuff that the scupper requires for connecting all the sites. Then I need to do scupper token. If I want to secure all the connections, what I need to do is create a token that is shared across all the sites, so they know how to encrypt and decrypt the information that is being transferred. So I create a token and I share this token to all the clusters. I do scupper link and basically automatically transfer this token to all the clouds. And basically, that's almost all the things that you need to do. Finally, you expose the service. Just say, okay, this is my service, and I want to expose it. Remember that at the beginning I said a scupper let you define a fine or granular network. So you are not exposing all the services that are here and all the services that are here. You're just exposing this service and this service, okay? Because you are exposing this explicitly. And that's great, because it means that in this cloud I can have a lot of services running, but only the ones that I set are the ones that are going to be exposed into the scupper mesh. So let me start with the first example. Here you can see all the examples as well. I'm just going to deploy an application with a front end and a back end, and I've got two clusters, and in one cluster I will deploy one backend and one front end, and in the other backend and the other cluster I will deploy the same backend. So I will have the backend replicated in two clouds. Well, if you follow, you've got the link at the end of the slides. So if you can just check later. So first of all, I'm going to deploy to my first cluster, which is this one. This is hope that the token has not been expired yet. Well, I can wait. Let me go here. Thank you. Oh, see. Let me do the login here. Yes. And then here I'm going to deploy the first of all the backend. Okay, now I've got the backend deployed in one of my cluster. Now I'm going to deploy. You can follow everything here, but now I'm going to deploy the same backend, but in another cluster. But first, let me set this environment variable, because you'll see in a few moments why this is important. Okay, now let me log into the other cluster. Okay, this is the other cluster. So I'm going to deploy the same backend as I mentioned it before. Okay, but now instead of let me change this. One is name it sandbox. The other one, let's going to call it. I think it's in Amazon. So, okay. Now, if you check the here, which is okay. Maybe it takes a bit of time. Carol get pods. Okay, now you see that I've got the backend here running. now I move again to the other cluster. Yeah, this is a bit of moving from one cluster to another cluster, but here you see that I've got exactly the same backend. So I've got two backends, or the same backend, right? Two different instances of the same backend in two different clouds. Now, let me deploy the front end. I don't know why. Let me deploy the front end in the here. Okay, here. Curl apply -F to front end. So now, curl get pods. You see that I've got in this cluster the front end and the back end. And finally, I'm going to apply some egress rules for basically to access this application. So now I can go here. Okay, now it's not working. Why? Now, okay, you can see here the application, and now I'm just starting. Okay, and I say hi, and I say aloha hi, and it comes, oh, sorry, yeah. Now, I mean that all is good, but I've not applied any scupper thing. So now I've got one backend in one cluster, another backend in another cluster, nothing else. Then let me start applying a scupper, right? To apply a scupper, and it's here, I need first of all to init a scupper. I need to a scupper or init a scupper in cluster 1. And this is the cluster 1, yes. I'm going to init. So basically now I'm just creating all the proxy things of a scupper. It takes a bit of time. You see here how it's, you see that it's starting all the scupper things like the scupper proxy, the scupper route, and so on. To close this now. Okay, now I'm going to create, as you can see here, the token. Okay, this is the token that's used for the communication between the services. So now the token is done. And finally, now I move to the other cluster and I initialize the scupper and copy this token. So let's do OC login to the other cluster. Okay, kubectl get pods. Okay. Wait a second, because maybe. Yeah, that's what happens with all these clusters at the end. I never know in which cluster I am. No worries. I mean, this cluster is going to be destroyed in 2 hours. So, not here, here. Okay, let me log in. Okay, now kubectl get pods. Yes, kubectl apply -F. One backend. Okay. kubectl set AWS. Okay, now, oh, let me change it to, let's call it Google. I think it's better. Okay, now, here, yes, now I've got here the backend. Now I'm going to do the scupper init. So I'm installing scupper again. You see here how this is one of the cluster, this is the other cluster. You see here I've got the backend and the front end, and here there is only the backend. Now a scupper is connected, and finally I'm going to do the link. That basically is the copying the token that I created to this new cluster. So I just copy it. And yeah, now you can even then do this command. You can run this command to know which are the services that are exposed between the sites. And you see that this says that this is the hybrid cloud. Now, yes, now all it's configured, connected, and so on. Remember, I've got 2 clusters, and this is the URL. I'm going here. Oh, sorry. That's not it. What is the front end? Between here. Okay, now I do hi. And I say, hi, AWS. It's the first cloud, okay? Now, I'm going to simulate a failure on this backend. So I'm just going to simulate a failure on the AWS cloud. So now it's, see that the backend is down. And I'm going here, and what is here? And I'm going to say goodbye. And now you see that switch to Google. And I've not done anything. I've just deployed both of the backends in both of the clouds. Then I got it a front end. And for any reason, the backend goes down, and automatically Scopper detected that that service of the AWS cloud was down, so it moved the traffic automatically to the Google cloud. What happens if at some point this is recovered? I said, oh, now I'm recovering, and again, this backend is up and running. And I'm going here, sorry. And I say, I don't know, Atlanta. Now it gets back to AWS, doing nothing, just rerouting automatically the traffic. And this happened because by default, Scopper tries to send the traffic to the closest node. So I defined the same backend in 2 different clouds and a front end. The front end is the one who connects to the backend. Then by default, the same cluster that has the backend has the front end. So it's the closest one, so it's the one that uses. But if this backend goes down, then automatically knows, oh, I know that there is another backend in another cloud, which is, it's the same backend, but in another cloud. So now that my backend is down, I'm going to automatically route the traffic to the other backend. Okay? This is how Scopper works. Now, let me check in which cluster I am here. Okay, this is the, I'm going to undeploy this application. Oops. To prepare for the next demo. Okay, now I do a scopper delete. So it's, it's removed, and now I'm going to do an OC login to queue of cattle get pods. Now I'm in the other delete -f of the ingress, the front end, and the backend, and Scopper delete. So now I've got both of the namespaces again clean. Now you've seen that you need to run all these commands all the time, which is okay. You do Scopper init, then you do Scopper create, Scopper link, and so on. But at the very end, you need to find some other ways of doing this more automatic. Okay, more like, okay, I want to run a command more in a DevOps way. And Ansible, offers you, apart from the Scopper CLI, 2 other ways of configuring. The first one is using a Kubernetes operator. So basically, it offers you a Kubernetes operator. You put there all you define your YAML files with all this information of, oh, I want to do a Scopper init, and then I want to do, a Scopper create the token, and then the link, and so on. So you do all this kind of stuff in a Kubernetes way, or also, and I usually explain this other tool, also Ansible. Okay, you can use Ansible for deploying all these infrastructures. And I mention Ansible because not always it's possible to have Kubernetes. Sometimes you've got one Kubernetes running in one place, then another one you've got virtual machines, then another in edge computing. So if you want to standardize how you deploy everything, then Ansible is your solution. You know that Ansible basically is that you've got a control node that connects using SSH to the managed node, so the nodes that you want to configure. It opens an SSH connection and starts running commands to that managed nodes. Okay, basically just here offering a bit of introduction, super fast introduction to Ansible, but basically Ansible has the concept of the playbooks. This is the YAML files where you define all the steps that you want to execute, and then you've got the inventory. These are the list of nodes where you want to apply something. And this inventory can be a Kubernetes cluster, can be a virtual machine, can be wherever you want. So let me show you again a different example now, but using Ansible. This example is also here, okay? And basically what we're going to do now is deploying a backend in one cloud and the database in another cloud. Then, every time that I need to do a request, automatically Scupper will send the request or the SQL query from my application to the other cloud. Okay? So, it's a way that you've got to keep privacy issues. For example, if you've got any customer that says, hey, my customer data cannot go outside of the country borders, then I can install a database there and run the backend in one place and the database in another place, and transparently connected and being secure. Okay? Now, let me show you how you can run it. I've already created this basically. With Ansible, you can also apply YAML files. And that's what I'm doing here. I'm just going to use Ansible for applying the YAML files and configuring a Scupper. This is what I am doing here. It's not very important. Then here, one of the things that I want you to notice here, this is the YAML file, a Kubernetes YAML file, for configuring the backend. This is the config map. And see the config map? It's a job application. I'm using the JDBC. I'm saying, hey, connect. See, the data, it's in this JDBC or this PostgreSQL server. And you see here, it seems that it's like a Kubernetes service running in the same cluster as the backend, right? Because you see that here, it's just say, oh yeah, it's Postgres, right? It's not an external IP. But you'll see that even though this is a local host name, this host name refers to the remote database running in another cluster. That's what the beauty of a Scupper, that abstracts you from external IPs, external host names, everything. For you, as a developer, you are doing a local connection. And it's a Scupper who detects that you want to connect to an external database and then do this translation. Okay, this is the YAML file for deploying everything. And then here is the, it's the inventory. In the inventory, you define the what clusters you've got. Here you see that I've got one cluster, and this is another cluster. And then here is the playbook where I deploy my application, and then finally I start Scupper. Now, I think that everything should be correctly configured now. I'm going here, and I'm going to run this. Maybe we got some kind of authentication problems. Well, we'll figure it out. Hope not. Okay, now you see that it takes a bit of time, but basically it's installing a backend in one cloud, the database in another cloud, installed all the Scupper, creates the token, distribute the token across the cloud, and well, it's doing, all this stuff, but it's doing automatically. And done, okay? Now, see that this is one cluster, and I think that this is in another namespace. It's here in this namespace. You see that I've got here the Postgres. So here I've got the database running in one cluster. And then I've got here another cluster that it has also, this is the backend. So I've got the backend. Here there is no Postgres running. The Postgres is running in another cluster, but, and that's important things, the config map points as a local service. And why this works? Well, because if I go here and you see all the services, working services, you see that there is a service named Postgres. But this Postgres is not a Kubernetes, it's not a standard Kubernetes service. It's a Kubernetes service, but you see that it says scupper route. Basically what it means is that every time that my backend sends a request to Postgres DNS name, which is a Kubernetes service running locally, basically it sends the traffic to the scupper router. And then the scupper router knows, oh, you want to connect to Postgres, okay, the Postgres is on another cluster, so I'm going to connect to the other scupper router, right? So you see here that this is a scupper router, and here is another scupper router, right? So I'm just doing this connection, and then this scupper router say, okay, now I'm redirect this to the Postgres. Okay, now if I go here, you can see this in action. Yeah, here is normal, but if I go to person, basically this creates a query, a SQL query that sends to the database. You see that it returns me elements. So, thanks of a scupper, without changing anything in my code, I'm able to connect to another cluster using, as you've seen, the local name, the local host name, if you will. Now, oops, not here, here. Key aspects of a scupper. Simplicity, that's one of the things. No code changes. I mean, you can run your application with the backend database in the same cloud, and at some point say, okay, now I want to move the database to another cloud. You can do it. You don't need to change anything in the host name part. Scupper will do this translation, okay? No network changes. It works, at level 7 application, so you don't need to change anything. If your application works, it works. You've seen that in my case, in these two clouds, I'm not in one cluster I'm the administrator and the other one not, but still I can connect. And as I said, no admin privileges, nothing, it just works. In fact, you can even try this and run kind or minikube in your computer and in an external cloud, and a scupper using the MQTT protocol is able to connect to your laptop. Even though you are in a dynamic IP with, with your firewalls and so on, if you are not blocking the port 8080, for example, then it's able to connect. As I mentioned before, you can use the CLI tool. There is also a console. For these examples, it's not necessary, but when you start having a lot of services, all of them exposed in different clouds and so on, there is a console that lets you check, for example, all the topology, who connects with who, the throughput bytes, and so on. There is the scupper operator. So if you are trying to connect two clusters, or two Kubernetes clusters, then you can go with the scupper operator. The problem with the scupper operator is that to install it, you need administrator privileges. So okay, if you are able to install it, that's great. If not, remember that you've got Ansible. Also, it's about portability. Thanks of containers, we make it, we turn it or competing workloads portable. So now we can create a container and we can move it, the same container, running in my laptop, in pre-production environment, in production environment, and it's always the same. Then, at some point, thanks of Kubernetes, we were able to do the object storage portable. Okay, we know with all these volumes and so on, you're able to store data in different file systems transparently, right? You just create a volume and that's all. But network was not portable. Now, thanks of a scupper, the network is portable. You've seen that maybe in Amazon, I've got some kind of network topology. In Google, another network topology, but it doesn't matter. Scupper makes these connections easy, make them portable. Then, everything is protected. Remember that I said that all the connection in a scupper uses TLS encryption, means that it's protected. No problems, you're right, meaning that It's all good. And another thing is that only exposes the services that you want. So you see here that there is a lot of services, but here as well and here, but you are only exposing this service and this service. Not all the services running in an namespace, but specifically these services. And that's something really good. You're getting network isolated, let's say, for free, without firewalls, VPN roles, or IP tables, nothing. It just comes for free. Also, it helps you a lot on the hybrid interconnections. Remember that I mentioned it at the beginning, that with a scupper, you're able to send traffic across all the scupper mesh. You can have here a virtual machine running legacy application, then here you can have a Kubernetes cluster, this is another Kubernetes cluster, and this is a database running in bare metal. You're able to connect to all these environments in the same way. Also, as I mentioned it, Scupper always tries to connect to sites that are not directly connected. Here you see that if I want to connect from as a request from this to this, from this to this, then Scupper is smart enough to say, okay, I just send it the traffic here and then here. I mentioned here. Okay, what happens if there is a, an outage? No problem. It can find other ways to arrive to the cluster. You see that, okay, this is the faster way, but if there is something goes down, right, for example, these connections, then a scupper said, okay, I'm just going to find an alternate path. And even if you want, you can define cost to the connections. So you can define that the connection from here to here is this cost, from here to here this cost, from here to here this cost, and from here to here this cost, okay? Cost, maybe it's because, I don't know, this is a super expensive cloud, so you want to try to avoid requests to this cloud. Then you define this cost in the connections, and always a scupper will try to find the optimal path to reach the destination, okay? So you say, okay, if I want to go here, if I do this, it's $8 or $10. If I do in this way, it's $4. So obviously, it's cheaper this connection, so this is the one that I'm going to follow. Then, as I mentioned, you can just scan. There is a lot of free books in developers.redcat.com. I showed at the beginning the ones that I wrote, but here there is a lot of others. Like if you are interested in Backstage on developer portals, there is also the book, also Quarkus for Spring developers, the Modernizing Enterprise Java, Java in a Nutshell, Podman in Action. So you've got all these resources there. You only need to register. You register, and then you can download them for free. Part of it, you can just get access to cheat sheets and things like that. So, thank you very much. We still have, it's like 10 minutes for questions. I don't know if there is any question. Yeah?
So the enterprise has a TLS certificate. That's a certificate you will link up with all these different clusters and on-prem servers.
Yeah, so basically uses to encrypt all the communications, basically uses this token, okay? And it's something that you can configure a scupper to take it, but at the very end, for all the scupper mesh, you need to create this token.
Okay. A specific token, or you can use the existing enterprise?
Yeah. I think that you can use, so you can explicitly set which token you want to. Yeah, I mean, you can do it. But yes, scupper, let's say, simplify you, if you will, getting started by just providing all the infrastructure for creating the token and so on. Yeah, but you're right. I mean that. Yeah.
And then if the different cloud, right, and they may have their own tokens, connectivity, and all that. So that, how will you do that if you understand what I may have an Azure cloud and I have a GCP cloud, right? I want to get data from the GCP cloud. And the GCP cloud system, they may have their own tokens, right? Or own. Should the weight the same? You originate, wherever originating, you create the token, and then that should be shared?
Yeah. So if you want to, so all the clouds that you want to interconnect, needs to use the same token. Yeah, common token, yeah. Yeah, this is, let's say that this is the way that the scupper has to maintain, let's say, the mesh altogether, right? Yeah.
So it's, will it work with this? We already have mesh Istio. We're using Istio.
Yeah.
Will that scupper still work within that, or is it different from?
Yeah, it's different. I mean, that a scupper, that uses the same approach, which is having a proxy, because this is what Istio does. It just has this sidecar container for this hybrid. In this case, it's not using Istio. I mean that you don't need to install Istio. You just create this scupper router and that's all. Yeah, but it's not. You do not need Istio for anything.
But you already have Istio for within for your just your this current application. You still have scupper over there.
So you mean
I have applications running on Azure. Right?
Yeah.
I'm using Istio mesh for within the applications for that, right, from the front end to the back end. So if then I want to get data from TCP, right?
Yeah.
I can still use scupper on both.
Yeah. Exactly.
So you said Ansible, Terraform will work as good with this, or?
Yeah, for a scupper you've got the CLI, the Kubernetes operator, and well, there is also this Ansible plugin. Apart from, that you can just make, all the, at the end you've got the CLI, so you can just run CLI commands. Sorry, that?
Terraform. Can you use Terraform script for deploying?
Other questions? Sorry.
Okay, sorry.
It's okay, sorry. Yeah, next question. Yeah, on the very first slide, or one of the earlier slides, you had listed some of the challenges connected to different platforms. But do you still have to kind of overcome those challenges to get Scupper to work? And then after that, you can start piling on different services within each platform.
Yeah, you mean this, right?
Maybe, yeah, I believe that was it, or it was the next one where you listed
This one?
Yeah.
Okay.
Right, so do you have to overcome those challenges once for Scupper to work, and then once you've done that, you can add multiple services inside of the Scupper mesh, and that starts communicating. Right, so you still need to connect your
Yeah.
cloud.
Yeah, exactly. Exactly. But you don't need, you don't need a public IP or, it just works. Okay, because it creates this, because it's using the thing, and or where the magic is, and this is this one, is that it's using this protocol, the MQP, that is what it lets you connect clusters. As I said, it's some kind of magic, because you can have your kind cluster running in your computer and have your public cluster somewhere, and you can just define that this public cloud needs to access your computer. And you do nothing, and it works. It can connect, because it uses this protocol. This is something it's like it's a layer 4 protocol that lets you do this kind of connections without having a public IP or, Oh, any other? It will be around, so you can just feel free to. Oh yeah, you look. This you want? Oh, you want the QR code? Yeah, okay. Well, I just move it here because if you got this link and you got the QR, but here. How that?
Load balancing works in all this.
Oh, yeah. Well, basically, it's just the balancing is like, as you've seen in the first example, I've got the front end, I've got the back end. The close, so basically, it just checks which is the workload close to who makes the call, and it does this. It's like, okay, this is the closest one. Then I'm just keep there, and if something happens, then I go to the let's say the expensive ones. But also there is an annotations where you can set at what point you want to switch to another. So it's like, okay, no, I don't want to wait until the backend is down. You can say, okay, if there is like, you have to this threshold, then start sending traffic to the other cloud, right? And when the threshold goes down, then it gets back to the yeah. There are some examples in the Scupper website where you, for example, you can use knative, so serverless, right? So then it's super, you can just mix serverless with the Scupper, so then you can even get, better flows of the workloads, yeah. And even if you check, there is also the one thing that is great of a Scupper is that since it's at application level, it works with any application. So, for example, you can use, for example, or you can create a PostgreSQL cluster and deploy some nodes in one cloud and some other nodes in another cloud, but magically, all the database is in the same. It looks like it was in the same cluster, but it's in different clusters, and it happens transparently. Okay, so thank you very much and enjoy the conference.